We've used strings a whole bunch so far, particularly in programs where we're just doing simple printing, or we want to display a message to the user before we take in some input from them, like in the temperature conversion program. Today, let's learn a little bit about strings and some more details about the kinds of things we can do with them. So strings are really just this sequence of characters. We mark them off with double quotes, and you can see a couple of different forms. Here we just have a regular string literal, hello world. Here we have a string literal that we're assigning to a variable called name, and that variable is of type string. And here we're doing that declaration and assignment in two separate steps. We'll learn more in the future about what precisely arrays are, but for now you can think of strings as arrays, basically as a series of gym lockers. In each locker, we stick one character of the string, and the lockers start at number 0 and go for however long the string is. You can see here we have this string called Pirate Yell, and it has 20 characters numbered from 0 to 19. Now, we're going to work with strings a lot of the time as if they are primitive data types. At least so far we've seen that. I mean, we don't have to instantiate them explicitly using the new keyword, the new reserved word, but in reality strings are objects, and we'll learn a little bit more about what that means practically for us shortly. One of the things we can do with strings is concatenate them or join them together. We do that using the plus operator, the plus sign. So here's what that looks like. Declare 4 strings, first name, full name, last and first. Okay, first name and last name we initialize. Well, look, if we want to make the full name, just do first name plus and then a space, because we want to have a space between the two, and then plus last name. So here we're actually concatenating 3 strings, 1, 2, 3, first name, space, last name. For last then first, we just switch the order, add a comma in, so you can see what the outputs will be. Now what that means is we've seen the plus operator mean 3 separate things. We've seen it as the unary plus. That has a really high precedence. That's like in this example, int result 1 equals plus 1. The unary plus really just means this is positive 1. We've seen it as addition with numbers, so int result 2 equals 1 plus 2. And now we've seen it with concatenating strings. Result 3 equals sup bro. So we'll learn more about this in the future as well, but we call this idea overloading, right? This plus operator is context sensitive. What it does depends on what kinds of inputs we give it. So in this case, if we're giving it the input of 2 strings, the plus operator acts as a concatenation operator. So that's overloading. You can concatenate strings and numbers as well. And basically what happens is that number is automatically converted to a string once you do the concatenation. So if we have a string message, 2 variables, X and Y, 20 and 35, we can concatenate them in a message. Dang, are you really X? You look at least Y. So that's how numeric variables interact with the concatenation operator when we're working with strings. Now, what you got to keep in mind is that concatenation takes the same precedence as addition. So if you take a look at these examples, these are a bunch of different situations involving concatenation and addition. So this first example, number plus 3 plus 4. Well, first the number and the 3 are concatenated because we're going left to right, and then that string number 3 plus 4 turns to number 3, 4. In the second example, the parentheses change the order of evaluation, and so we end up with number plus 7, which is number 7. Third example, well, the multiplication still has a higher precedence than concatenation and addition, so we end up with number 12. In the fourth example, okay, 3 plus 4 plus number, because we're going left to right again, that's 7 plus number, which turns to 7 number. And finally, 3 plus 4 number. Okay, well, that's just a syntax error. Okay, great, so we caught that. So we've seen escaping characters before as well. We saw it with the new lines, we saw it with tabs. Here you can see it with quotes. And this turns out to be really important when we're trying to build strings. Ignore the curliness of these quotes, that's just a matter of the font. But you can see the orange quotes are actually escaped by the backslash. I mean, it really means just take this literally, not as the end of a string. These are a couple of the important escape characters other than the quote. Tab, new line, backslash, we've seen those before as well. Take a look. What do you think this is going to print? What gets escaped? And what effect does it have? So we end up with 1, 2, 3 escaped ends, which give new lines. This 3 and 4, the end doesn't have a backslash, so we end up with just 1, new line 2, new line 3 and 4, new line 5. Here we have backslash, backslash, and then the word backslash. Well, that first backslash escapes the second backslash, and we end up with just a backslash backslash. If we're looking at this, system.out.print what time. It's maybe hard to read, but that second T is escaped, so we end up with what tab I'm. Last example for now, system.out.print. Oh, this is ugly. This is real ugly. Well, let's just count. This first backslash escapes the second backslash. This third one escapes the fourth one, so that's 2 that we have. The fifth one escapes the sixth one, so that's 3. This backslash escapes this T. Okay, so that's 3 backslashes and a tab. Then we just have a T. And then this second to last backslash escapes the final backslash. So we end up with backslash, 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 tab, T, backslash. That's gross. That's really just to see if you can get a grip on how all of these escape characters are going to play out. So we saw the metaphor of strings as a set of gym lockers where we stick one character in each locker. Now, this is important. As we said before, strings are objects. They're not primitive data, and so they have methods that we can use to work with them, just like all of the other types of objects we've worked with so far, like scanners. So in this case, one of the crucial methods that we have to work with them is the char@at method. And basically, it allows us to take a string and figure out what character is at a particular index in the string. So here, I've declared a variable called 9th char, and that's of type char. So I say, okay, pirate yell, that's the name of my string, pirate yell.char@9. Okay, so I'm saying take the string pirate yell and give me the character at index 9, and it looks like that's actually a space here. So if I print out 9th is concatenate and then 9th char, well, we end up with just 9th is. Likewise, if I do system.out.println pirate yell.char@0 plus exclamation point, well, the character at 0 is S, and that ends up with an exclamation point. The length method is another example of a method we can use with string objects, and just tells you the length of the string. Okay, so here we've got a string that we've declared. It's called butFirst, and we've got an int that we've declared called the length. In this third line, we actually instantiate a new string object. Let me take a selfie. It happens implicitly because we're allowed to work with strings in that way by Java. And then let's see, the length equals butFirst.length. So we take the name of our string and we call the length method. If we print that out, it's going to print 21. That's the number of characters here, including spaces and punctuation, not including these quotes. One more method that we often use is the equals method. And just to really stress this, strings are objects. They're not primitive data types. So in the same way that if we had two numbers, we might use the double equals operator to test whether they were equal or not, we can't do that for strings. We have to use the equals method. So let's go back to the example from the last slide. We have string butFirst equals let me take a selfie. Okay, if we did if butFirst dot equals let me take a selfie. So if what's in here, which again is right here, equals the same thing as let me take a selfie, then print out the two strings were equal. Now in this case, this actually turns out to be false, right? Equals returns true or false. This turns out to be false because the equals method is case sensitive. So this capital L and this lowercase l throw it off. Now there's also a method called equals ignore case. And if you were to do butFirst dot equals ignore case, let me take a selfie, well then you're good to go and you'll end up getting true. Okay, so a couple things before you close up shop. First, you want to make sure you know how to concatenate strings and also how you concatenate strings and numbers. You also want to know how concatenation works with the other operations, addition, multiplication, and so on. You want to make sure you can use escape characters effectively for quotation marks, tabs, new lines, backslashes, and do problems like the ones that we just did a couple of slides ago where you're predicting how exactly escape characters will affect the final string. You also want to be able to get the length of a string and store it in a variable, and know how to get the nth character of a string using the char@at method. Cool. See you next class.